Everybody got a calculator too? Okay, what we're gonna start with today is when we have common bases. Common bases make everything easier. So in my first one, I have 5 to the x power equals 125. How can I write 125 as a power of 5 so that they have the same base? 5 to the third. So I'm going to write 5 to the x equals 5 to the third. Guesses on what x equals? 3. Once you have a common base, all you're doing is setting our exponents equal. Okay, kind of like we've been doing. Okay. Next one says 6 to the 2x power equals 216. I want to get 216 to be a base of 6. How would I do it?
Times 1 or x is 1.5, right? 6 to the third.
6 to the third. So 6 to the third is 216. Now that I have a common base, what should I set equal?
2x.
Good. 2x equals 3, so what's x? 3 halves, 1.5. How do you want to write it? Okay. Question so far? Alright. In C, I need to write 1 over 49 as a power of 7. How do I do it? Negative 2. Why negative? Yeah. The 1 over is my negative part. And then obviously 49 is 7 squared. Okay, now what I'm setting equal? Good. 4x equals negative 2, so what's x? Negative half. Okay. So always try to get the same base. Makes everything easier. Okay. What about D? I want to make it as a base of what? 3. So 3 to what power gets me 27? You said 20? 3 to the what power? Third. 3 cubed is 27. So what am I setting equal?
2x plus 5.
Good. 2x plus 5 equals 3.
2x equals -2.
Subtract my 5 and I get negative 2. So 2x equals negative 2 and x equals what? Negative 1. Perfect. Okay, questions on that one? Okay. Do I have the same base in E? No. So should I try to make 2 a base of 8 or 8 a base of 2?
8 a base of 2.
8 a base of 2. So we're going to write, that just sounds weird a little bit. Like a tongue twister. How can I write 8 as a base of 2? 2 to the third. Okay. So I have 2 to the third. That's just replacing my 8. Okay. So we're going to go like this. And then I still have my x minus 7 power. Okay, is that okay? Okay, what's different about this one is that the 3 is multiplying my my exponent that's already there. But it's multiplying both of them, okay? You can't just write 3x minus 7. You have to distribute this 3. Okay, so if I distribute the 3, what am I getting over on the right-hand side?
3x minus
Good. And I'm setting that equal to what since I have a common base? 2x plus 5. Okay, questions on that step? Okay, how do I solve from there? Plus 21, so I get 26 equals, subtract my 2x and I get, right?
Are we supposed to fill in the blank?
You just need common bases. questions on solving with a common basis?
So you take your negative 21 and subtract this.
Yeah, so subtract your 2x from 3x, get x. Add 21 to 5 and get 26. Other questions? Okay. Alright. Can I take 5 to some power and get 130?
You can get close.
I can get close, I can get 125, but I can't get 130. Okay. So what we're gonna do is, as long as your base and exponent are isolated, okay, so I only have one base and an exponent, we're gonna take the log of each side. Okay? Logs are kind of like undoing exponents, kind of like a square root in a way. Okay, so what we're gonna do is we're gonna write log out front of each of these. So we're gonna take the log of each side. Okay. When I have a log with an exponent, yesterday what did we do with the exponent? Bring it out front, okay? Now notice 2x is my whole exponent, so we're gonna bring the 2x out front, and then we have log 5 equals log of 130. Okay, so to get our exponent down, all we do is take the log of both sides. Okay. Remember yesterday when we plugged in a log of whatever number? That's just a number, okay? Just like e to e squared is just a number, okay? So in order to get x by itself, the first thing we're gonna do, this is a times, right? We're gonna divide by log 5. Okay, so we're gonna have 2x equals our log of 130 and divide by our log 5. Okay, questions through here? What here?
With the logs cancel.
In calculators, take log of 130 divided by log of 5. Okay, so we're what?
3.
12.
0. 0.
Did everybody get this in their calculator? Okay, then how would I get x by itself? Divide by 2. And we get x to be 1.512. Okay. Questions? Okay. In B, can I take 7 to some power and get exactly 800? Probably not. So we're going to do the same thing. First thing, as long as this is isolated, which it is, there's no like plus or minus anything over here, we're going to take the log of each side. Okay. Again, I have an exponent. What do I do with it? Bring it down. So it becomes 4x log of 7 equals log of 800. Questions on that step? Okay, now what do I do? Divide the logs. So I'm going to divide by log of 7. And what do I get? 3.435. You got what? Okay, so here we want to round kind of big. So try to take like 3 decimal spots. Last thing, divide by 4, and I get Yeah, what number though?
0.859.
Questions? Okay, let's keep going. I got 3 plus 5 to the x power equals 217. Is my exponent by itself? Or my base exponent? No, it's not. I got that 3 out front. How do I get rid of this 3? Add it?
You subtract.
Subtract it. So I have 5 to the x power equals 214. Is 5 to some power 214 nice? No, so what do I gotta do?
Log.
Take the log of each side. What happens with my exponent? X log 5 equals log 214. And last thing to do? 5. So x equals 3.33. Okay, last one of this kind. Is 7 to some power 28? No, so what do I do? Log. So what happens to the exponent? Out front, the whole thing out front. So I got 3x plus 1 log of 7 equals log of 28. I'm going to put parentheses around this actually. Because it's not 3x plus log of 7, it's 3x plus 1 times log of 7. Now what? Got logs. So I get 3x plus 1 equals 1.712. What's my next step? Minus 1. So 3x equals 0.712. Now what? Divide by 3 and I get 0.237. Okay. Questions on solving with logs? We use it when we cannot take whatever base is there to some power and have it come out nicely. Okay. Last problem of the day. For notes, that is. Wood. It's nice. Your lumber company has 1,200,000 trees. You plan to harvest 5% of the trees each year. How many years will it take to harvest half the trees? First off, what's half of the trees? If I have 1,600,000. I got a rate of, what's my rate if it's 5%? Point what? 0.05. I want to know how many years. What kind of function am I looking at? The growth and decay one, yeah. Not your PERT one. PERT is like only dealing with money compounding continuously. Okay? So if I want in so many years 600,000, where's that going? Is that my initial amount or the amount I want over time? Over time. So I'm going to put this out over here on its own side. What's my initial amount? .120000. Okay, is it a growth or decay function? Decay. So I take 1 minus my rate, which is what? 0.95. And I don't know how long it will take. That's what I want to find out. Divide by the very large number. And what do I get? What do you mean you don't know? We know this is half of this, don't we? Isn't that what we hope to have? Half? How am I going to get that T down? Magic. What kind of magic? Good kind. How do we get it down to the last 10 problems we just did? Logs, which is funny because we're talking about trees. Ha ha. So not funny, I think it's hilarious. So I got the log of 0.5 equals, what am I doing with my exponent? Bring it out front. 10 log of 0.95. How am I figuring out how many years? Oh, the log. Well, about how many years is it going to take? 13.5 years. So whenever you're looking for your exponent to get it down and solve, we use our logs. Questions?